Out in the cold, dark depths of our solar system, far beyond the orbit of Saturn, lies a giant, a blue giant. This is Neptune, the eighth and farthest planet from our Sun. It wasn't discovered by peering through a telescope, but by pure mathematics. Astronomers noticed something was tugging on Uranus's orbit, something massive. Their calculations pointed to a new planet, and there it was, right where they predicted. Neptune, named after the Roman god of the sea, is a swirling ball of blue, its atmosphere whipped by supersonic winds. This blue hue comes from methane in its atmosphere, absorbing red light and reflecting blue back at us. It's a gas giant, much like Jupiter and Saturn, but it's the methane that gives Neptune its distinctive, almost ethereal blue. Our journey takes us deeper, past the swirling blue atmosphere of Neptune, to one of its most enigmatic companions. This is the story of Sao, a small moon with a big story to tell. Neptune's moons are as diverse as the planets themselves. There's Triton, the largest, a captured world with nitrogen geysers erupting from its icy surface. There's Nereid, with its eccentric, elongated orbit, taking it farther from Neptune than any other moon in the solar system. Each moon dances to a different tune, dictated by Neptune's gravity. But one moon stands out, not for its size, but for the mysteries it holds. This is Sao, a moon discovered by analyzing images from a spacecraft. Sao, named after a nymph in Greek mythology, is a dim and distant world. Its surface is a canvas of greys, pockmarked by craters from eons of impacts. We know little about its composition, about the secrets hidden beneath its surface, but even from afar, Sao beckons us. It's a reminder that there are still uncharted territories in our solar system, places where no human eyes have ever gazed. Sao's story is just beginning. Sao's discovery wasn't a deliberate hunt, but a serendipitous find. It wasn't found by staring through a telescope, hoping to catch a glimpse of something new. Instead, it emerged from data, from the meticulous analysis of images taken by a spacecraft billions of miles away. It was the summer of 2002, and the Hubble Space Telescope was busy at work. Its mission to observe the Neptune system, to capture images of the blue giant and its entourage of moons. Hidden within those images, amidst the pixels of light and shadow, lay the telltale signs of a previously unknown world. Sao emerged from the darkness, not through direct observation, but through the careful analysis of data. Behind every great discovery is a team of dedicated individuals, their minds working tirelessly to unravel the secrets of the cosmos. Sao's discovery was no different. A team of astronomers led by Matthew J. Holman, a scientist at the Harvard-Smithsonian Center for Astrophysics, was tasked with analyzing the data from the Hubble Space Telescope. They were looking for anything unusual, any faint points of light that might betray the presence of a new moon. The team used a technique called image subtraction, essentially removing the bright light from Neptune and its known moons to reveal any fainter objects lurking nearby. Little did they know that their dedication would soon pay off, leading them to a discovery that would rewrite the textbooks on Neptune and its moons. The search for new moons is a game of patience, of sifting through mountains of data, searching for a faint signal in the noise. The team had to account for the movement of Neptune and its known moons, carefully aligning the images to cancel out their light. They developed sophisticated algorithms, computer programs designed to identify anything that didn't belong, any faint points of light that moved in a way that suggested an orbit. And then, one day, it happened. A faint blip on the screen, a tiny speck of light that refused to be ignored. The team was cautiously optimistic. They had a potential candidate, a faint blip that hinted at the presence of a new moon. But they needed more data, more observations to confirm their suspicions. They tracked the object's movement, carefully plotting its course around Neptune. The more they observed, the more confident they became. This was no stray star, no cosmic interloper passing through the Neptune system. This was a moon, a small icy world bound to the blue giant by gravity's invisible hand. And so Sao, the once hidden moon, emerged from the shadows, taking its place among the other members of Neptune's celestial court. Sao, despite its recent discovery, performs an ancient dance around Neptune. It's a tiny world, a mere speck compared to the immense bulk of its parent planet. Its diameter is estimated to be around 44 kilometers, making it one of the smaller members of Neptune's moon family. It orbits Neptune at a distance of about 22.4 million kilometers, tracing a path that's nearly circular. This stability is a boon for astronomers, allowing them to predict Sao's location with a high degree of accuracy. Each orbit takes Sao approximately 2,914 Earth days, or almost 8 years to complete. Gazing at Sao through our most powerful telescopes is like peering through a veil of cosmic dust. Its small size and immense distance make it incredibly faint, a ghost flitting across the backdrop of distant stars. The most prominent features on Sao are likely impact craters, the scars left behind by collisions with asteroids and comets over billions of years. These craters serve as a record of the chaotic early days of our solar system, when debris from its formation still littered the space between planets. The exact nature of Sao's surface remains a mystery, but its grey color suggests a composition similar to other icy objects in the outer solar system. This icy surface is likely a combination of water ice, frozen gases like methane and ammonia, and perhaps even darker organic compounds. Unveiling the composition of a celestial object is like peeking into its DNA, revealing clues about its birth and evolution. Based on its low density and its location in the outer solar system, scientists believe that Sao is primarily composed of ice. This ice is likely a mixture of water ice, the most abundant type of ice in the universe, along with frozen volatiles like methane, ammonia, and carbon dioxide. These volatile compounds, which exist as gases on Earth, freeze solid at the frigid temperatures found in the outer reaches of our solar system. The presence of these ices is particularly intriguing because they suggest that Sao might have formed in a different region of the solar system and later been captured by Neptune's gravity. Determining Sao's exact origin will require more detailed observations, perhaps even a dedicated mission to this distant moon. Sao, for all its diminutive stature, holds a universe of unanswered questions. Its surface, shrouded in shadow, whispers tales of ancient impacts and perhaps hints at hidden geological activity. Future missions, equipped with more advanced instruments, could provide the answers we seek. Imagine a spacecraft, specifically designed to study Sao, slipping into orbit around this enigmatic moon. By analyzing the light reflected from Sao's surface, scientists could determine the composition of its ice, searching for the telltale signatures of water, methane, and other compounds. Exploring Sao is not merely about unraveling the mysteries of a single distant moon. It's about pushing the boundaries of our knowledge. Sao, like all celestial objects, is caught in a delicate gravitational ballet. It's not just Neptune's gravity that dictates Sao's movements, but the subtle tugs of its fellow moons as well. This intricate interplay of gravitational forces creates a complex and dynamic system where even the smallest perturbations can have significant effects over time. Imagine a group of dancers, swirling and twirling around a central point. Each dancer's movement influences the others, creating a constantly shifting pattern of motion. By carefully observing the movements of moons like Sao, scientists can map out the distribution of mass within a planetary system. A Resonant Family. Within the intricate choreography of Neptune's moons, there exists a remarkable phenomenon: orbital resonance. This occurs when two or more celestial bodies exert a regular periodic gravitational influence on each other, due to their orbital periods being in a simple integer ratio. Think of a pair of pendulums swinging in sync, their movements reinforcing each other. In the case of Sao, it's engaged in a resonance with one of its larger siblings, the moon Halimede. These two moons are locked in a 4-to-5 resonance, meaning that for every 4 orbits Sao completes around Neptune, Halimede completes 5. This resonance is not just a cosmic curiosity, it has profound implications for the long-term stability of Sao's orbit. By keeping the two moons in sync, the resonance prevents them from having close encounters that could disrupt their paths. This gravitational embrace ensures that Sao's dance around Neptune will continue for eons to come. While orbital resonances can bring stability to a planetary system, they can also introduce an element of chaos. In the case of Sao, its resonant relationship with Halimede isn't the whole story. The gravitational influence of Neptune's other moons, particularly the massive Triton, adds a layer of complexity to Sao's orbital dance. Triton, with its retrograde orbit and immense size, acts like a gravitational bully, disrupting the orbits of its smaller siblings. This gravitational jostling can cause Sao's orbit to become slightly eccentric over time, stretching and squeezing its path around Neptune. This orbital chaos, however, is not necessarily a bad thing. In fact, it can provide valuable insights into the history of the Neptune system. By studying the subtle variations in Sao's orbit, scientists can reconstruct the past interactions between Neptune's moons and gain a better understanding of how this complex system evolved over billions of years. From our earthly vantage point, Sao's surface remains a mystery, its features hidden by its small size and immense distance. Even the most powerful telescopes can only reveal it as a faint point of light, a tiny spark against the velvet backdrop of space. Yet, scientists can make educated guesses about what might lie on Sao's surface based on its location and composition. Being in the icy realm of the outer solar system, Sao likely possesses a surface covered in various ices, not just water ice, but also frozen gases like methane, ammonia, and carbon dioxide. These ices, subjected to the faint but constant bombardment of solar radiation and cosmic rays, could create a surprisingly dynamic surface. The different ices would reflect sunlight to varying degrees, giving Sao a mottled appearance. Additionally, impacts from micrometeoroids, tiny particles of space debris, would leave their mark, creating a fine dusting of craters across Sao's icy plains. While much about Sao remains shrouded in mystery, its discovery serves as a reminder of the vastness and wonder of our solar system. Each new world we find, even ones as small and distant as Sao, expands our understanding of the processes that govern planetary formation and evolution. Future missions to the outer solar system, equipped with more advanced telescopes and perhaps even spacecraft designed to study these distant moons up close, could shed light on Sao's secrets. Imagine a probe diving through Sao's thin atmosphere, if it has one, analyzing its composition and searching for signs of organic molecules. Or picture a lander touching down on Sao's icy surface, drilling into the crust to analyze its composition and search for evidence of a subsurface ocean, a hidden reservoir of liquid water that could harbor the potential for life. These are just some of the tantalizing possibilities that lie ahead as we continue to explore the outer reaches of our solar system. Sao, a tiny moon in a distant corner of our cosmic neighborhood, may hold the key to unlocking even greater discoveries that could reshape our understanding of the universe and our place within it. In the grand tapestry of the cosmos, Sao might seem like an insignificant speck, a tiny moon orbiting a distant giant. Yet, for those who dedicate their lives to unraveling the mysteries of the universe, Sao holds immense value. Its very existence challenges our assumptions and fuels our curiosity. Studying Sao and other objects like it in the outer solar system is not just about collecting data points. It's about piecing together the story of our own cosmic origins. These distant worlds, untouched by the same processes that shaped our planet, offer a glimpse into the conditions that existed billions of years ago, when our solar system was still young. By understanding how these objects formed, what they're made of, and how their orbits have evolved over time, we gain a deeper understanding of the fundamental processes that govern planetary systems, not just our own, but potentially countless others scattered throughout the galaxy. Sao, in essence, is a time capsule, preserving clues about the early solar system that have long since vanished from the inner planets. Its study has the potential to rewrite our understanding of planetary formation and the distribution of water and other volatiles throughout the cosmos. Imagine traveling back in time to witness the birth of our solar system. Studying objects like Sao offers a glimpse into the distant past. Sao's composition and orbit hold clues about conditions billions of years ago. Methane and ammonia ices on Sao suggest it formed in a colder region. These findings help us understand our solar system's history. Section 3. Tools for Exploration. Exploring Sao requires cutting-edge technology. Ground-based and space telescopes provide initial glimpses. Next-gen telescopes will observe Sao in greater detail. A spacecraft mission could be a game-changer. Instruments would capture high-resolution images and analyze Sao's surface. Spectroscopy and radar sounding would reveal composition and subsurface structure. Gravity mapping would determine internal structure. Data would refine our models of icy moon formation. Section 4. Sao, a stepping stone. Sao, despite its size, represents a stepping stone to a deeper understanding of our place in the cosmos. It's a testament to human curiosity and our desire to explore the unknown. Technologies developed from exploring Sao will pave the way for future missions. Each discovery brings us closer to answering fundamental questions. Are we alone in the universe? How did life arise on Earth? What is the fate of our solar system? Sao may hold the key to greater discoveries. The journey has just begun. Section 1. A small moon, a universe of knowledge. Sao, a seemingly insignificant moon in the vast expanse of our solar system, has unveiled a universe of knowledge since its discovery. Its faint light, captured by our telescopes, carries whispers of ancient cosmic events, of gravitational dances and icy collisions. Though small in stature, Sao has challenged our assumptions about planetary systems and expanded our understanding of the processes that govern their formation and evolution. We've delved into the intricate details of its orbit, a testament to the delicate balance of gravitational forces at play in the Neptune system. We've speculated about its surface, a canvas likely painted with the scars of billions of years of cosmic bombardment and the subtle hues of various ices. And we've pondered its composition, a frozen record of the early solar system, hinting at the conditions that prevailed when our cosmic neighborhood was still young. Sao's story reminds us that even the smallest, most distant objects in our solar system can hold profound secrets, waiting to be unlocked by human ingenuity and our insatiable thirst for knowledge. Section 2. Our cosmic journey continues. As we stand on the precipice of even greater discoveries, with new telescopes peering deeper into the cosmos and ambitious space missions on the horizon, Sao serves as a beacon of inspiration. Its exploration is not merely about understanding one small moon. It's about pushing the boundaries of human knowledge and venturing further into the great unknown. The lessons we learn from studying Sao, the technologies we develop, and the questions we answer will pave the way for future generations of explorers, who will undoubtedly set their sights on even more distant and challenging targets. Perhaps one day, a spacecraft will touch down on Sao's icy surface, revealing firsthand the secrets hidden beneath its enigmatic exterior. Until then, Sao will continue to beckon us from the depths of our solar system, a silent testament to the boundless wonders of the universe and the enduring spirit of human exploration. Our cosmic journey is far from over, it's just beginning.